Good morning, friends. So today we will be wrapping up Hive quickly, and then we will start looking into Spark. So next 2 weeks we will predominantly spend a time on Spark. Okay, so probably the course might get into August second week. It might not be. We might not be able to wrap up by end of July as was planned earlier. I have asked for the extension to lab till August 15th, so that you guys have lab for practice. Okay, so now let's go ahead and start about Hive querying. So far we have seen how to create tables in Hive, how to load the data into Hive, and how to insert data into Hive. So as part of creation of tables, you need to deal with the delimiters, the file formats, whether you want to create a managed table or external table, etc. And when it comes to loading the data, you need to understand the differences between load and insert. Load does not use MapReduce, whereas insert actually perform MapReduce. So if you want to apply any transformations and then load that data into another table, you need to go with insert statement where it uses MapReduce to apply those transformations which are defined in the select query. For load, if you already have the pre-processed data and if you want to load data into Hive tables, then you can use Hive load command, which is very fast as it bypasses the MapReduce. But the constraint is that data needs to be pre-processed as per the structure of the table. There should be no deviations from the structure while loading data into the Hive table using load command. Now comes Hive queries. So again, we will go back to the Hive user guide. Okay. And then we have seen data definition, data manipulation, and then data retrieval. They mentioned as part of data manipulation itself, which they should not have done. It should be part of means it should be one of the main topics by itself. So here, if you click on this, it will give you the base the base syntax of the select statement. So here, if you look into this query, it is exactly same as traditional RDBMS queries, but there are certain differences which you need to understand. For example, in traditional RDBMSs, you never see sort by, okay, and distribute by, whereas in Hive, distribute by and sort by is highly relevant. Okay, and here other than the distribute by and sort by, rest of the stuff is same. Select the columns from the table from table name, where you can give whatever where conditions you want to filter the data, and group by to perform the aggregations as part of the groups, and order by to sort the data. And there is a caveat with order by, which I will explain in a moment. And that's why they have introduced a concept called sort by, which we will see into it. So before getting into writing any query, let's understand the problem statement. Let's review our data model and then try to understand try to define a problem statement. And based on that, we will try to write one single query covering most of the topics, and then I will cover distribute by and sort by very quickly. And if you want to understand it in more detail, I have videos on my channel. I will show you the reference for that. Okay. Yeah, so here I am connecting to the lab. So for freshers, it might be a little bit a little bit fast paced, and you might not be able to follow because this requires some knowledge on SQL. If you're not familiar with SQL, then you might struggle a little bit to follow with me. The solution will be to work on your SQL skills. You can go to W3 schools or um, any other free resources that are available to improvise on SQL skills. Eventually, within next 4 or 5 months, I will have my own course on SQL, PL SQL, etc. But for now, you have to use other sources to refresh your SQL skills. Okay, here I am connecting to the lab, and then I am connecting to the MySQL database. Okay, IT Varsity is the password. Use retail underscore DB. Okay, show tables. We have 6 main tables: categories, customers, departments, order items, orders, and products. So let's review the data model of these 6 tables. For that, you can go to Google and search for retail underscore DB Cloudera. Okay, so you will get this URL, getting started with Hadoop tutorial. And here, if you scroll down, you should see the data model. Where is the data model? I think it is in the next one. Next step. Wait. Yeah, this is the one. It's in the exercise 1 only. It just took some time to refresh this. So here, if you look into it, so in RDBMS, we typically see 2 types of data. One is transactional data, other one is metadata. Metadata means I will explain in a moment. So transactional data, if you think about any e-commerce platform or any retail platform, orders and order items are the common tables. Orders will have order level details such as when the order is placed, what is customer ID, who placed the order, and what is the order status, whether it is completed, pending, or whatever it is. And then order items is the one which is a child table to orders. That's why, so this represents 1 to n relationship. So for each and every order, there could be n number of order items. For example, if you go to Amazon website and if you place 10 products, each product might again have different level of quantity. So all those details are order items attributes. For each order item, you will have order item ID, order item product ID, and then order item order ID, which is nothing but the order ID itself, and then quantity for each order item, how much quantity we are trying to buy, what is the subtotal, and what is the product price. All those details are order item attributes, and for each order there will be n number of order items. Hence, there is a 1 to n relationship, and order items is the child table for orders. And now we need to have other tables which are non-transactional. So whenever an order is placed, these two will be updated. Okay, but there will be other set of tables which are non-transactional in behavior, which will store metadata of the information that is required while placing the orders. For example, customers. So when a customer want to place the order, he has to log into a system and then he has to place the order, and the system will capture first name, last name, email ID, password, phone number, etc. And those are all customer related attributes, and one customer can place n number of orders. That's why there is 1 to n relationship between customers and orders here. Similarly, the products will have the details about all the products, such as TV, Samsung 55-inch, a particular model TV, a refrigerator, etc. All those are called as products. And when we actually place the orders, we will try to place it should be mapped to the product. So all those details about the products will be in the products table, and one product can be sold as part of multiple orders, and the product will be part of order item, and hence we have 1 to n relationship, because each product can be sold to multiple customers through orders, through order items. there is relationship between products and order items here. And then products can be categorized, for example, electronics, footwear, etc. And here categories give the details at the category level, and products, for each category there can be n number of products. For example, electronics can have n number of products, and hence we have one-to-one relationship between categories and products. And then the categories can be further grouped into departments, and here we have one-to-one relationship between department and categories. So now let us query the table departments real quick and see what type of data we have. Select star from departments and hit enter. So these are the 7 records which are originally there in this table. So this is this data set is primarily for or this data model is primarily for e-commerce apparel platform. And here when it comes to apparel store, you will have fitness related stuff, footwear related stuff, golf related stuff, outdoors related stuff, fan shop related stuff, etc. I think it's only 2 to 7. From 8 it's all data which is generated by some of us. So only these 6 departments are there in an apparel store. One is fitness, one is footwear, one is apparel, one is for golf, one is outdoors, one is fan shop. And then if you query select star from categories, you can see there is a category department ID which is foreign key to the department. So in this case department ID 2 means fitness. So as part of fitness department, there are these many categories. There is a football category, soccer category, baseball and softball, etc. So like that you can query the data from rest of the tables, and you can understand the data model thoroughly. And now we will define a problem statement. So we have order date in orders table, and order item. For each order item, the revenue is stored in order item subtotal. Okay, and now at executive level, some executive VP want to see how each of his departments are performing. Okay, and on timely manner, not just overall, but every month he want to see how each of his department is performing. So in this case, if you want to if you consider revenue as metric for the performance of each of the department, he has to join departments, categories, products and order items to get the revenue for each department. And then on top of that, if you want to see the trend about how each of these departments are performing, which means he has to consider a date, which means he has to join orders table also. So in this case, we have to join all these 5 tables to get the revenue at department level on monthly basis, to so that the executive management can see how each of the departments are performing. So the problem statement is to get the revenue on monthly basis for each department, joining this monthly for each department on monthly basis. The solution will be to join all these 5 tables and then generate the revenue by using a select query if you are trying to perform this using Hive. Okay, so now we will start developing the query. Exit. Now I got into Hive. So if we want to generate the report on the transactional tables directly, you have to join all these tables. And if this report is being run on companies like Walmart, where you will have millions of orders, billions of order items, millions of products, and then thousands of categories and hundreds of departments, this join will be very expensive on the source level. And also when it comes to companies like Walmart, Target, etc., each store will be supported by a different database. And here we are not getting the details at the store level. We are getting at the enterprise department level. If that is the case, um, joining data from all the 4,500 databases of Walmart will be a nightmare. It is not possible at all. For that, we need to have a centralized data warehouse. That's where the data warehousing comes into picture. You have to get data from all the source databases into one target centralized data warehouse. And even after getting into centralized data warehouse, if you still implement the same model of having 6 different tables to support this subject area, it is not very practical. For that reason, we will have a dimensional model, and we will perform the joins and generate the metrics as the data is being loaded into the enterprise data warehouse using the design which I have explained earlier. And then you will hardly join these many tables to actually generate the reports. You will join 1 or 2 tables, and then you will be able to generate the reports, and the performance will be much better because you are dealing with a much lesser volume of data, and also you are dealing with very few tables to generate the report. Anyway, but to begin with, we will use the normalized model itself even in Hive and try to get the report, just to understand the capabilities of Hive, how the queries can be written. So here, show databases. Mine is use training 8634. My database name is training 8634, and here I can run show tables. And there are these tables: categories, customers, departments, orders, order items. So these are the 5 tables which I am interested in. So first we should validate we can actually get the data without any issues. Departments limit 10. So we are getting those 6 records. That is fine. The last 2 have some issues because of the mismatch between the data in files and the table structure which is defined. And then categories. So limit is the command to limit only whatever number of records you want to see. So categories is also working fine. So to preview the data, you should always use limit. And one more thing is, if you see, you are getting the results immediately, and it is not actually running MapReduce behind the scenes. Typically, all the select queries will run MapReduce jobs, except when you try to run select star from without any filtering or any other conditions. Okay, select star from table name or with limit, it does not use MapReduce. It will just fetch the records by fetching the data similar to Hadoop ss-cat command. It will try to fetch the data. Okay, I will answer that question. Let me validate these tables. Customers is also working fine. Customers is not required for this query. We require products. Products looks good. Orders, it looks good. And order items, it looks good. So all 6 tables looks good, but we don't need customers from this. So Mohan is asking, when you say use database name later, how can we know which database is in use in Hive command? And that's a good question for which I don't know the answer. Probably which database? No, there is no. I think there is no such feature, or there could be. I'm not 100% sure. I never earlier when I started my career in Hadoop, I tried to explore that. At the time, I didn't get the answer. After that, I never bothered to get the details. If you come across the answer, please let me know. Okay. As of now, I don't know. So now we need to join all these tables to get the revenue. Okay, so I will be using Sublime Text to write the query, because it will be tough for me to edit if something goes wrong as part of writing the query. Okay, so first Okay, Raj have responded to that question. Let me read it out. Okay, so you can actually set this parameter. Thank you very much, Raj. So you can actually set this parameter, and now the database is displayed here. Good to know. Okay, so now I will be using the Sublime text to write the query. So I will start with, you can start with any table, but afterwards you might have to play with the order of the table to get the better performance. But for now I will be focusing on functionality rather than performance. So I will start with departments and then categories. I will try to join with categories, so on up to orders table, orders and order items table. Okay, so departments D, join categories C on D dot department ID equal to C dot category department ID. That is the foreign key column in categories table, which is pointing to the departments through department ID. And then join products P on C dot category ID equal to P dot product category ID. Okay, join order items OI on P dot product ID equal to OI dot order item product ID, and then join orders O on OI dot O dot order ID equal to OI dot order item order ID. So all the joins are taken care. Okay, and then we have to group by department, group by D dot department name, or we can actually give the first column as the substring of O dot order date, because we want to get monthly trend. We want to aggregate at each department level by monthly. So O dot order date 1,7, comma D dot department name. Okay, so that is the group by clause. You can also have order by order month department name. Okay, so here in the order by clause, whatever column names you give in the select clause, you should define it here. Okay, now we are defining the select clause. Select, I want this one to get the order month. Okay, so we need to name it. If you want to use this column as part of the order by or sort by clauses, you have to give an alias, and you should use only that alias in order by and sort by clauses. Okay, for that reason we have, it's a very good practice to give aliases for all the expressions here, especially if the expressions are functions such as substring. Okay, and if you want to get the list of functions that are available, you can just say show functions, and you at least you have to scan through all these functions over time. Most of them are self-explanatory. One of the important area which you need to focus is manipulating the dates and converting the dates into strings and strings into dates, etc. Okay, which I will not be covering, which you have to explore to gain more and more knowledge in Hive to get better at it. Okay, and on top of order month, we need the department name. I don't need department ID as part of my report. Instead, I need department name, so I am using D dot department name here, and then I want to get the revenue. Okay, and revenue is part of order items. So OI dot order item subtotal. Let me confirm the column name. Describe order items. Order items subtotal. There is no underscore after sub. Okay. So this is how you can write a query which includes joining the tables, grouping the tables, computing the aggregations, and then sorting the data also. And now we can actually copy, paste this query and hit enter. Now you can see that it has to run 2 MapReduce jobs in the background to complete this complex join query. Okay. So one MapReduce job is not good enough. It has to perform 2 MapReduce jobs to complete this. And typically, when you try to join very large tables, it could be more. In this case, it is using a concept called map set join when it is trying to join the tables, and hence it is only using 2 jobs. So depending upon the size of the tables and other criteria, the number of MapReduce jobs can be different. And if you want to understand all those details, I will recommend you to go to my channel. I will create a course for it very soon in LMS platform. But for now, you can go to my channel, search for Apache Hive. There should be a playlist for Apache Hive. So you can go through these videos. I have covered most of the important stuff here. Or another dimension to learn this effectively is by going to building EDW. There is a playlist for it. Okay, you can go to these videos and you can get expertise in Hive. The reason why I'm not covering all the aspects of Hive is to focus more on Spark. Okay, the next 2 weeks we have to understand the Spark in detail. That's the more important stuff than anything else. After that, Hive is the most important stuff. If you have any questions as part of the Q&A, I will try to answer those questions. But I'm just laying the foundation about how to write the Hive queries. There are some questions which you might face as part of the interviews, especially very important questions. I will try to record some videos on those areas so that you have the consolidated list to face the interviews, to face the questions, whether it is interviews or as part of the design discussions. That way you will get a little bit more confident. Okay. So this is how we can write the query. Now you can see for each month, for each department, we are getting the revenue. And if you, in this case, I have sorted by department name. If you want to sort by revenue, you can do that also. You can just give order revenue as alias here and give that alias as part of the order by clause and say descending. Okay, so I hope all of you guys are familiar with SQL, and if you want to sort in ascending order, you just have to say the column name. Ascending is default, but if you want to change the order of the data, you can actually say it as DESC, and the data will be in the descending order. So now we can use this query and store data in a table and export it into reporting layer using scoop export, and from there the reporting layer can actually generate the reports. So you can use this logic to perform the ETL on your dataset and move the pre-processed data into the reporting layer, and the reporting layer will only got into these aggregated tables which are very small and light, and your reports will perform much better. So ETL is offloaded to the Hadoop layer, and reporting will work only on the aggregated tables. Okay, so this is how the overall life cycle of building an analytics platform on Hadoop will work. First, you get the data from sources, process the data in Hadoop, and then load into the analytics or reporting layer from which visualization will happen. Okay, now let us get into some nuances and very important differences between traditional RDBMS queries and Hive queries. The first difference is in traditional RDBMS, the queries will be working in their proprietary fashion. Each database will work in different way. Whereas in Hadoop, when you try to submit Hive queries, the queries will be compiled into MapReduce jobs, and those MapReduce jobs will be executed on top of the queries. On top of the data which is in HDFS. Okay, so syntactically it follows ASCII. If you try to join the data and all those things, you have to use ASCII syntax only. You cannot use some native syntaxes of databases such as Oracle, where you say orders O, comma, order items OI, where O dot column order ID equal to OI dot order item order ID. So this type of joins are quite common in Oracle, but this is not valid in Hive. You cannot actually perform joins in Hive by joining tables like this, which is typical in Oracle world. Okay, that is one of the difference. And also in regular RDBMSs, you write queries such as this: select star from orders O, where or order items. So if I want to get all the order items details from for the orders which are completed, then either I can join order items and orders, and also it works like this, where order item order ID in select star from orders where order status equal to complete. So this query is valid in most of the traditional RDBMSs. In the in clause, you can actually give a subquery. I think it is called as correlated subquery or something. I do not remember. Or nested subquery. You can give this query as part of the in clause, but this query will not work in Hive. In clause in Hive, you can only give the literals. You cannot pass the subqueries. And also in traditional RDBMSs, you have something called scalar subqueries. Scalar subqueries are the ones which you can actually specify the query in the select clause, blah blah blah, and then here I am just putting a placeholder. You can have a valid query which will retrieve only one column and one row in the select clause, and then you can have other columns C1, C2, etc., and then you can select from a table. So you can have a select query as part of the main select clause itself, and this is called as scalar subquery. And scalar subqueries are also not supported in Hive. So there are many of these conventional queries which might work in traditional RDBMSs, might not work in Hive. It follows ASCII standard. Joins happen like this, and it works group by works, having works, order by works, everything works. But there are some differences which might work in traditional RDBMSs like these ones, which will not work in Hive. Okay, so in these scenarios, you might have to break down a query into multiple queries and come up with a solution understanding the capabilities and limitations of Hive. Okay, that being said, another very important difference, and which is available only in Hive, is distribute by clause and sort by clause. Okay, so sorting is one of the area where traditional RDBMS struggle, because sorting does not follow linear, means you cannot achieve linear scalability with sorting. So for example, Hive is primarily to perform the distributed computing similar to parallel in Oracle. If you are familiar with Oracle databases, you have a hint called parallel, and you can use parallel hint to get the data using parallel threads and process the data in parallel threads. But even when you use parallel, if you have queries which are using group by clause, order by clause, etc., which requires some sort of sorting, and the parallel degree does not work as expected. It will become serial and single threaded, and the performance will drastically go down depending upon the volume of the data. So the queries will not scale based on the volume of the data, which means that, for example, let's say to process 1 million records using order by, if it take 1 minute, I'm just giving hypothetical numbers, it can vary significantly, but the main idea is to give you insight about nonlinear scaling of traditional RDBMS on sorting the data. So if you have 1 million records, it will take, let's say it is taking 1 minute to process the data, especially including sorting. If you have 2 million records, ideally, if it is using the same capacity for both the queries, if it is scaling properly, then it should not finish, it should not run more than 2 minutes. But as sorting requires a lot of memory, and it will become single threaded, the 2 million records, when you try to process the data with the same parallel degree, instead of taking 2 minutes, it might take 3 minutes or 4 minutes. It will the time will exponentially increase with the linear increase of data, which means that the complexity is order of log n rather than order of n. No need to get into those complexity terms, which is a little bit complicated, and I am not very good at that. But typically they use the order of n for linear scalability, and order of log n to explain logarithmic scalability. So in this case, it follows the logarithmic scalability. So as the data volume grows, the execution time can grow significantly, okay, which means that it cannot scale properly. So when it comes to sorting the data, there are two types of use cases. One is global sorting, and second one is sorting within a key. For example, in this case, when we run the query, here I don't need to sort globally for each day or for each month. Within the month, I just want to sort by revenue in descending order. In that case, there is no point in sorting globally. Similar is the case with, let's say you have, let's talk about another use case. This will make it simple. So take the example of Walmart again. They have 4,500 stores, and if you want to understand, if you want to understand in each of the store which product is performing better, or top 3 products in each store. So if you want to identify top 3 products across the enterprise, then you have to sort the data by product, by product revenue globally. There is no easy way to break it down into pieces. But if you want to just see within a store or within a region what are the top 3 products, in that scenario, the global sorting is not required. Within each store, you just have to rank by revenue of each product, and you should be able to get the results. So you should be able to achieve higher degree of parallelism, at least by sorting only within the group. So that's where Hive adds value. So using the distribute by clause and sort by clause, you can actually distribute by a particular column, and then within that column you can actually sort the data. Because it is not performing global sorting, the performance will be much better than traditional databases. Still, it might not scale linearly, but the performance will be much better. So Mohan is asking, sorting may be equivalent to partition by in Oracle terms. No, that is not the right comparison. Partition by, are you talking about partition by in the queries or while creating the tables? What are you talking about? And whether you talk about either of them, it's not similar to that, it's different. So you can actually, so partition by in queries does not work the way Hive works. It's completely different. That is called as windowing functions. You have that also in Hive. Hive supports windowing functions also, but what I am talking about is significantly different. It's only to sort faster compared to traditional RDBMSs. I don't want to get into those things at this time. It's complicated and other people will get bored. But the main difference between traditional RDBMSs and Hive is traditional RDBMSs have only order by, whereas Hive have both order by and sort by. Order by for global sorting, and sort by is to sort within the keys, as I have explained earlier. So if you write sort by, the scalability will be much higher. There will be more number of reducers which will try to process the data, and the performance will be better. So if you want to perform hands-on, again you can go to my channel and go to this button, this search, and go to performance tuning, and here do you have this here? No, I don't have this here. Probably it should be in the EDW playlist itself. If you go to the EDW playlist, yeah, I think if you get into this, you will understand more in detail. I have even demonstrated practically how it works. I think this says only theory. There should be demo also for this. Let me check. Probably I might not have added that to the playlist. So this actually consolidates all the differences with RDBMS. Go through this building enterprise data warehouse Hive videos. It covers quite a bit. Yeah, I think it covers the demonstration also. Let me quickly validate.
Shadi is finally happening. What are we wearing?
If not, I will try to record a video on that. Yeah, actually it actually demonstrated. I have demonstrated it as well. Okay, using deck of cards, I just showed how order by is different from sort by. I will highly recommend to go through this video, because this is very important point, especially when you face the questions. If you explain to this level, and your interview will go to a different level. So make sure you watch this video to understand with practice the difference between sort and order. And also I will highly recommend you to run the queries using similar approach on actual data, and try to focus on the numbers, how much time it has spent on CPU and how much time it took for the execution and all those things. It will give some insights about how sort by can be better than the traditional order by when we use Hive. Okay, so that being said, let me take few questions on Hive. If you have any questions, I will answer those things, and then we will start a highly important topic of the course, which is Spark. So yes, you can actually get the explain plan in Hive. You just have to say explain plan for and give the query. You will get the explain plan. And tips for performance tuning. Yeah, if you go to my building enterprise data warehouse playlist, there are things covered here, high performance tuning strategies. The list is not complete yet. I will try to add those videos very soon. So I have covered compression in detail. I have covered how to play with split size and number of reducers to improve the performance, and there are few more things which I need to cover, which I will be taking care probably this week. But this is a very good starting point. And also in general, when it comes to MapReduce based tools, if you want to understand performance tuning, you can watch the playlist for performance tuning here. Performance tuning Hadoop MapReduce, and these concepts are similar and applicable irrespective of the tool you use. And here I have explained from the Hive context also wherever it is relevant. Even though it says Hadoop MapReduce performance tuning, it covers Hive based tips as well as part of this. It covers compression, it covers how to deal with too many small files and many other things. So you can go through these things. What is the good resource for Hive practice? So the good resource will be to get into the language manual and start exploring the syntax, and then start practicing and exploring all the capabilities slowly. I have emphasized only the important aspects of Hive, but to explore it further, you should be able to understand this language manual in detail. So there are some advanced concepts such as XPath specific functions. Those things you can ignore. Whatever makes sense for you, you keep on practicing using the dataset which is provided by Cloudera, that retail_db, and you should be able to explore most of the stuff. For example, we have covered loading and inserting the data. Update and delete, which is called as Hive transactions, are not very important. You can ignore them. It has very limited capabilities, and we should not use regular insert, update, delete type of operations in Hive. You should not do that. So you start from this, and you start exploring all the relevant stuff, and try to apply this on top of try to apply this on top of the retail DB dataset which we have got as part of the Cloudera distribution, and also which is already available in CloudX Lab. So Mohan is asking the question, how will we take care of update clause like loading fact on daily basis? So typically fact tables are inserted on regular basis. We hardly update the data. Okay. So if it is insert only fact tables, it is very straightforward. You get the delta from the source tables, you apply the transformations and load into the fact table. So when updates need to be performed, and if it is inevitable, typically updates happens on the dimensions, not on the fact tables. So on the dimensions, there are multiple types of dimensions. One, there could be dimensions which are very small, and if you have to update, you just get the data from source and replace with the existing data in the target. That is easiest way to have the snapshot of the source data in dimensions on target. But if it is slowly changing dimension, and if you want to capture the history of your dimensions, again, that is a very straightforward thing. You just have to get the delta or whatever modified data from the source and load into the Hive table, Hive dimension, slowly changing dimension. But there will be scenarios where a type 3 dimension has to be implemented, wherein a few fields has to be updated. In that scenario, it is little bit challenging. You have to come up with Hive merge strategy, and you have to run you have to stage the incoming data from source into a stage table, and then you have to perform this merge operation. Scoop provides a merge operation, so you can use scoop merge to merge these two datasets into final dataset. You will not be able to update each and every record at a time. You can use scoop merge to take care of that for you. If scoop merge does not work as expected, then you have to come up with your own custom solution to merge the data the way you want into the table in enterprise data warehouse, be it fact table or dimension table. You have to follow the similar strategy, but in a well designed data warehouse, you hardly update data into fact tables. So you do that into into dimension tables, and at times you have to come up with custom solutions. In some cases, you can also use HBase as a layer in between, and you can actually update the data through HBase, and the data will eventually be stored in HDFS itself. And then you can create an external table on HBase, and you will be able to fetch the data as part of your Hive queries, and you will be able to join with other fact tables to get the desired metrics for you. So there are multiple ways to deal with that scenario. How good to use HBase as wider solution for dimension? It is a good solution. We have implemented that in the past with IBM successfully, and it works well. It is similar to type 2 dimension. If you want to go with a different type of dimension, then you might have to customize quite a bit. But the thing is, you cannot directly store data into HBase the way you typically load data into traditional RDBMSs. Probably you might have to have intermediate application which can read the data from the files and load into the HBase table. That could be Java code, or that could be MapReduce code to load into that HBase table. So it is not out of the box solution. You have to use HBase and then develop a tool on top of that to load data into HBase tables to simulate the dimensions, which will be updated at regular basis. Scala and HBase integration is not seamless. So recently one guy was asking the same question. So when you try to use HBase, Java-based development is desirable at this time, because Scala integration between Scala and HBase has few issues. So you might have to use traditional MapReduce to process data which is there in HBase, or even to load data in HBase. So there you have to use Java. Okay, can you please tell strategy to generate surrogate keys? So so the way we have used when it comes to implementing HBase is we use the timestamp, and then we have so we have developed a MapReduce application, and as part of the MapReduce application, you can get the metadata where your application is running, which node your application is running. All those details can be retrieved. So using that information, we actually generated a custom key, and we use that key to as a surrogate key when the data is loaded into HBase. When it comes to Hive, we didn't use surrogate keys because it's very tough to generate surrogate keys in Hive. With HBase, yes, because we can write the MapReduce job. We can generate the surrogate keys by leveraging the features that are available in MapReduce. Even when it comes to Hadoop, if you have to generate, when it comes to tables in Hive, if you want to generate surrogate keys, instead of using insert command, probably you might have to come up with custom MapReduce program where the MapReduce actually generate the surrogate key and load into the target table. In recent past, they might have come up with a solution, but I'm not aware of based on my experience. No, you cannot call MySQL function in Hive queries. It is not possible. You have to create user-defined functions using Java-based APIs. Again, I think that is covered as part of building enterprise data host playlist. Yes, you have to use Java-based APIs to create UDFs. But when you use Spark, there is Spark SQL, and you can use Scala-based or Python-based APIs also. So let me show you sample code about how a Java-based Hive user-defined function will look like. Okay, so here Hadoop NYSC source main Java, not this one, Hadoop. EDW, no, not this one. Yeah, getting started. Have a sample query. Just give me a moment. I will try to go by pip. So go to code. Yes, it should be in Hadoop only. It should be in NYSE source main Java. Yes, so this is the package analytics NYSE Hive UDFs. Okay, so this is the path, and here I have date translate function. So this is how it looks like. So you have to implement a few Hive APIs by extending UDF class to generate, and then you have to override this function called evaluate, and then you have to compile into a jar file. You have to add that jar file and create temporary function in Hive. And on top of this is called a simple UDF. On top of this simple UDF, there are other UDFs also, like UDAF, user defined aggregate functions, and UDTF, user defined tabular functions. I don't have examples for that, but this is how you can develop user defined functions in Hive. Again, you need to have a little bit of Java background to perform this. Okay, so let's start with Spark. So now let us understand what are the limitations about Hadoop which requires systems like Spark. So if you look into this, it took 77 seconds to run this query, and if I use the same query and run in MySQL, so this same query should work in MySQL because I have written using ASCII syntax. And you see it just took under a second, whereas in Hive it took 77 seconds. Okay, so MapReduce based solutions such as Hive, which uses a good amount of IO as part of the processing the data, works well when you try to process terabytes of data. But if you have few gigabytes of data and if you have to quickly process the data and generate reports out of it, then MapReduce based solutions might not be good enough. So due to this limitation, if you want to report on the data that is already there as part of Hadoop ecosystem, you have to develop a data integration platform where data that is processed in Hadoop is pushed to a reporting layer. Let me show you that slide again. So recent here, yeah, let me open this. And if you look into this picture, if we try to directly report from Hadoop cluster bypassing reporting database using Hive, and if the reports has to be refreshed based upon the user selection to provide interactive and ad hoc capabilities, you cannot do so, and you have to get the data to the reporting database, and then you have to develop the reports on top of it, which is unnecessarily aggravates the timelines, or unnecessarily extend the timelines for the implementation of your project. Okay, and also as more code needs to be developed, it can be error prone, and there could be bugs, and you will unnecessarily waste a lot of time. So if we can actually connect to Hadoop and get the data, is it only with Pramod or is it for everyone? Can you guys hear me? Hello? Hello, can you guys hear me? So Pramod, probably you might have to restart, means reconnect. He could not hear us. Pramod, you have to reconnect. Everyone else can hear me. Okay, so now this is the issue. Means if you want to introduce another layer in between, this could be significant issue. If we have a solution where we can actually connect to Hadoop directly and start providing the interactive reporting, that will reduce a lot of issues, and that's where many tools came into picture. Hortonworks came up with a product called Tez, which bypasses MapReduce and uses yarn itself to actually process the data in a little bit different fashion and get the results faster. Okay, so the same query, I am exiting from MySQL, and now I am launching Hive, and I am setting Hive execution engine to Tez. Okay, and running the same query. And hit enter. So here instead of 70 seconds, it took 19 seconds. So it is relatively much faster than MapReduce based approach. And similarly, there is an Impala from Cloudera, and there is a product called DataMere. So all these things actually try to address that problem of moving data to a reporting layer when we try to use Hadoop ecosystem. So these products such as Impala, Tez, and even DataMere up to a certain extent try to address only the reporting issue, reporting layer in real time or near real time fashion or interactive fashion. But if you want to, sometimes what we have to do is we might have to get data every 5 minutes, and we have to process that data whatever is received in that 5 minutes, and then apply some analytics on top of analytic algorithm on top of it, and then we have to dump the data again in some layer in like Hadoop. For those kind of scenarios, if you try to use MapReduce, if you are getting a few gigabytes of data every 5 minutes, and if it takes more than 5 minutes to process that data, then there will be a lot of backlog as we proceed over time, and there is no solution for that problem using technologies such as Impala, Tez, or even DataMere, and they only solve the reporting issue. So they need faster and effective solution to solve the problem of micro batches. So if it is macro batch, if you try to process terabytes of data every few days or few hundreds of gigabytes of data every day, MapReduce based solutions will work on very large clusters. It can process the data in timely manner, and you will be able to see the aggregate the results and start reporting on top of it using Impala or whatever layer you want to use to report for the reporting purposes. But for real-time analytics or micro batches, those does not work, and there we need an effective solution. And Spark is the one which can provide that solution in both the areas. Spark is very effective as part of the reporting layer, and also it is very effective as part of analytics layer, where we have to analyze medium-sized data in quicker fashion. Spark can be very handy, and how Spark works and all those things, I will go to that point later. And on top of that, writing MapReduce programs is tedious. So if you want to join two tables, just two tables, if you have to develop a MapReduce program for that, it will take at least 100 or 150 lines of code. You have to read the data from HDFS for both the tables. You have to write mappers for both the tables, and you have to write very complex join-based algorithm leveraging MapReduce APIs, and it takes at least 150 to 200 lines of code just to perform simple join using in two tables using Java-based MapReduce approach. For that reason, Spark actually came up with support using functional programming languages. So you can use functional programming languages such as Scala, Python, etc. on top of Java to actually perform a lot of operations such as joins, etc. With fewer lines of code. Using Python or Scala, if you want to join two data sets in Spark, you just have to write 5 lines of code and data will be joined. Okay, so that's using Scala or Python can reduce your development timelines drastically. And on top of that, if you want to develop a data integration platform, okay, you have to get data from Scoop, and then you have to run some Hive queries by applying transformation rules to transform the data. And then if you are not using Impala or Tez, you have to again push the data to reporting layer, and this has to be connected. And either we have to use tools like Oozie, or we have to come up with our own custom solutions to connect all these things and work together, which is very, very tedious, because Scoop uses its own way of its own syntax and semantics to run the command to import the data. Hive has its own syntax and semantics. If you want to use Pig, you can Pig has its own syntax and semantics. And integrating all these things, you have to use a different programming language, and that programming language, if it is shell scripting, it is different from all the other tools which we are being using, and hence standardizing can take a big standardizing will become very big task, and also the effort will be very bug prone, so you will end up in a lot of bugs and all those things. So developing using traditional Hadoop ecosystem tools is very, very tedious. With respect to Spark, I will just give a demo, and you will understand what it is all capable of, and then you will realize how one tool can work taking care of all these things. Okay, now I will try to give the demo in Scala. So I am starting Spark using Spark shell command, which will launch Spark based command line interface using Scala as programming language. If you want to launch Python based command line interface, you have to run PySpark. So Spark shell is for Scala based command line interface for Spark. PySpark is Python based command line interface for Spark. Okay, so now if I have to using Scala, if I want to connect to source database using JDBC, for example. So here I am going to my GitHub code and go to Hadoop, EDW, Cloudera, Spark, Scala. Okay, so you can actually run Spark shell with this. I'm exiting and I'm launching with this jar file. We can add it after launching also, but I have this as part of my GitHub repository, so I'm using this command. And then if you want to run a query connecting to a source database, you can do that through via JDBC. You can connect to your MySQL database. For that, you don't worry if you don't understand what I'm doing here. Just try to focus that I'm connecting to the source database and getting the data into Spark. How the data will be stored in Spark and all those things will be covered a little bit later. Okay, here I have to create SQL context. So this is the command, and then this is just another string variable called URL which is being generated, and here we have provided the JDBC URL, database name, username and password, and then we can run this command called SQL context.load. I will come back to that in a moment. Okay, there is some syntax difference. I think it is because okay, first let me check whether we have the jar file in this location. Probably the location might be different. Okay, copy this one and shell new tab with settings. ls-ltr. Yeah, there is one. Then why it is failing? Let me see. Probably the syntax might be incorrect. It might be for 1.2. In this case, it is 1.6. Anyway, I will try to fix the code. But this is how you can actually connect to the source database using JDBC, and you will be able to fetch the results. And someone have asked a question. Let me check the question. So Pramod, again, please ask the questions publicly so that I don't, even if I forget to read loud, read the question, people will follow. So SQL context is already available as it's shown on the console. So if you read it through, it is talking about, yeah, very good point. Probably that could be the issue. Thank you. So if you see it here, it has created SQL context with Hive support. So the current SQL context is pointing to Hive. So you can actually submit Hive queries through Spark. So that's why it is showing, means whatever is available is from Hive context, not the Spark SQL context. To run these queries, we need to have Spark SQL context, not Hive context. Okay. So now let me change this password here and try. IT Varsity. Yeah, I don't think that is the issue. There is some other problem. I think this is for a little bit older version of Spark, which is why it is failing. So I will try to fix it. I will try to fix the code in the GitHub. It is very straightforward. And then, as we have seen, we can also run the Hive queries. Okay, Hive context. So here this is how you can change now the context back to Hive and run Hive query. So now it has connected to Hive, and we can see the results. Again, there is some issue. Native Snappy library not available. The version of lib Hadoop was built without Snappy. Okay, I am using the incorrect departments. So let me, someone have stored data in default database with snappy compression, and as of now snappy is not enabled here, that's why it is failing. So we need to check with CloudX lab guys to fix this issue. So here I am giving the database prefix 8634 dot departments. Okay, and now let us try. Yeah, now you can see that it is working as expected. So the beauty of Spark is you can submit Hive queries, and it uses Spark framework itself. The syntax, even though it says it is using Hive context, the Hive metastore will be used to compile the query. Once the query is compiled, it will not use Hive MapReduce to compile to run the queries. You can see it here. It is actually using the Spark framework itself. We will try to understand all these details as part of the next class. But the beauty of it is you can connect to the source database, fetch the data and process. You can connect to the Hive database, fetch the data and process. And you can apply Spark custom capabilities also using Scala or Python as programming languages, and you can take care of whatever transformations you want to do. So using one programming language, now you can actually get the data from the source database on daily basis, and you can actually join the data which is already in Hive tables with the incoming data. And if you want to apply a transformation similar to pig when you try to deal with unstructured or semi-structured data, those transformations also can be done within Spark itself using one unified programming language. And as everything is part of one application, you don't need to have a wrapper program to connect all the dots like the way we have to plan with traditional tools. So that is why Spark is getting a lot of traction. Your development life cycle will be much more efficient, and also the processing is a lot more efficient because it uses memory to process the data. The processing will be faster, and also the same Spark can be used to present data as part of the visualization layer. Because of all these features, Spark is getting lots of traction. And on top of that, most of the enterprises already have high-end hardware. When it comes to high-end hardware, the storage will be typically network mounted, and they will have higher memory like 128 GB, 256 GB, 512 GB RAM on each of the hosts. So now Cloudera started proposing to build the clusters with fewer nodes rather than hundreds of nodes the way it was done earlier traditionally. Now they are promoting smaller clusters, 10 node cluster with 256 GB RAM or 10 node cluster with 512 GB RAM, because when you have lot of RAM and as Spark uses memory very efficiently, the network traffic will go down significantly. Because as you have fewer nodes in the cluster, automatically the data that needs to be transferred over the network also go down significantly. So that's the reason why Cloudera and even Hortonworks have changed their strategies towards Spark starting from 2016. If you go to the certifications of Cloudera, there is no certification on Java-based MapReduce APIs anymore. So there is no Java. They try to get away from Java completely. Cloudera is trying to get away from Java completely. Hortonworks still have one certification based on Java MapReduce APIs, but they are getting a lot of requests for Spark certification also. So that's why they have introduced the Spark-based certification recently, which is not stable yet. Means even the information is not reliable because it's just started with 15 days or 1 month back. And they have realized that the number of guys who are giving Java-based MapReduce API certification have gone down significantly. Even they are not getting any training requests on Java-based MapReduce APIs. Instead, they are getting training requests on Hive, Scoop, Pig, and then Spark, and eventually Spark will dominate Hive, Scoop, and Pig, because using one unified platform, you can achieve all the things that Scoop, Hive, and Pig can give to you. So that is why it is very important for you to spend a lot more time on Spark and get better at it. Okay. So we will get into the details about how Spark works. Before wrapping up today, I will try to explain how you can get the information about the Spark using documentation provided by official official documentations provided. Okay, so just go to Google and search for Spark documentation. Okay, you can click on this one, documentation Apache Spark. You can go to the latest release, and here you should focus on Spark programming guide. Okay, so this covers core Spark, which will be part of the course. So I will explain what in the core Spark is. So on top of core Spark, they have introduced Spark streaming, Spark SQL datasets and data frames. So I will be covering core Spark and data frames as part of this course, and then MLib, machine learning libraries, GraphX. So MLib is to implement machine learning algorithms, and GraphX is primarily to implement graph algorithms. On top of Scala and Python, Spark also have Java based APIs and R based APIs. You can go through these things to go through the documentations related to them. So primarily you should focus on this Spark programming guide to build the core, to build the skills on core Spark. And even in this, the main things which you should focus on are transformations and actions. If you can understand transformations and actions, that's a very good starting point. On top of that, you have to learn a little bit of Scala programming and Python programming. It's a different story. But when it comes to Spark based APIs, you should primarily focus on transformations and actions. If you can understand these things, you will be able to clear this CCA certification very easily. Okay, and I will be covering most of these most of these APIs which are part of core Spark, which is transformations and actions, and that we will start as part of the next class. So there is a question from Pramod: in CCA certification, why do they test Spark knowledge using both Python and Spark? Is it something to do with the industry currently? Yes. So Python and Scala, I understand your question. So Scala is the for that you need to understand how Python works and how Scala works. What are the advantages of having Python, and what are the advantages of having Scala? Scala is a functional programming language. The syntax looks like a scripting language or Python, and on top of that, it provides object-oriented features also, object-oriented concepts features. So if you want to develop modules which are object-oriented, then Scala is a better solution. And also MLlib is I think originally developed with Scala. If you want to implement machine learning algorithms using MLlib, Scala is the way to go. And also there are products which came up which were developed using Spark Scala for Spark. So if you want to develop the modules based on those available third-party tools, then Scala comes handy. And Python itself have many machine learning algorithms like NumPy, SciPy, etc. And if you want to develop a module leveraging those things, you might have to use Python. So there could be a scenario where a single project has to be modularized in such a way that one module might have to be implemented using Python and another module will be implemented using Scala. In that scenario, having knowledge of both will work. You can leverage the best features of best features of both if you have knowledge about both. So that's why they are testing both. And also, especially these certifications will be given by services industries. Product based companies, they don't care. or even the end clients, they might not care about the certifications much. So for services in companies such as Cognizant, Infosys, and even the consulting firms like Deloitte, Capgemini, etc., if they want to bid the projects, some clients might prefer Python, some clients might prefer Scala, as both are similar programming languages. If a person is certified on both the programming languages, uh, it give a little bit of traction while bidding the projects from the end clients. For those reasons, they are trying to test both Scala and Python. Um, Whereas if you see the latest certification from Hortonworks, the certification, you can choose one programming language, either Scala or Python, and you can execute the entire all the questions in one of the programming languages. You don't need to execute in both the programming languages. But for CCA, you have to be competent enough that you can leverage Spark APIs as part of the given Python code as well as Scala code, and then just you have to fill the gap with Spark based APIs using Scala as well as Python, and you will be able to answer that question. You don't need to be expert Scala or Python developer at the time of giving the certification. So the next question is, which distribution certification is best at the moment? So again, it all depends upon the upon your current status. As you are new to this, I will highly recommend CCA. If you are already HDP CD certified on Pig, Hive, and Scoop, then you should consider HDP CD Spark certification rather than going into CCA. Instead of covering the redundant topics, it's better to give HDP CD Spark from Hortonworks itself, where it tests on core Spark plus Spark SQL and data frames. CCA does not test on Spark SQL and data frames, but it touches core Spark, and then it touch Scoop, Hive, Impala, etc. So if you are new to the certifications in Hadoop in big data ecosystem, I will highly recommend to go with CCA. If you already have some certifications, then based upon your current scenario, you have to explore all the different certifications. They are equally valued, and then you have to spend the money where it adds value to you. So in that context, I have created a blog in www.itversity.com, and you can see there is Hadoop and Spark developer certifications FAQs. If you go through this, you will understand what all certifications that are available, and here I have explained how to choose the certification. So for you, as I know your background, Venkat, it will be better to go with CCA. So Pramod is asking another question: would running code in Python have more overhead than running code in Scala or vice versa? Yeah, Python is loosely typed. You do not tell data types anywhere in Python. As it is loosely typed, as it has to evolve, as it has to understand the data type of the values which it is getting implicitly, it spends more time compared to Scala, and Scala spends more time compared to Java. Scala is a little bit slower than Java, and Python is a little bit slower than Scala. But as we are talking about distributed computing frameworks leveraging memory, this overhead is negligible. So you don't need to worry about that overhead. Yes, there will be a little bit more overhead, and it will be slower if you run a single threaded application using Python, but at scale, when you are using memory to process the data, the whatever overhead it will bring onto the table is completely negligible and can be ignored. So I can take a couple of more questions if you have any. So make sure you join from the next class so that we actually talk about Spark in detail. Sure, Venkat, you can call me within 30 minutes. We can talk, or you can call me in the morning if it is too late for you. So another question from Pramod: do they use Java in writing Spark programs since the buzz is mostly around Python and Scala? Yes, some companies who have good Java programmers, they don't want to spend time in learning new programming languages. For those companies still use Java, and I am getting requests to upload content using Java because they have to use it as part of their job. So still they use. Mohan, how much deep we need to learn Scala for Spark? So for certification purpose, you just need to scratch the surface. You don't need to get into too deep. You just should be able to write functions in Scala. You should be able to. You don't need to worry much about object-oriented concepts of Scala. Just core programming syntax of Scala is good enough. How to write for loop, how to write, how to print the data from a collection, and few set operations, which I will be covering as part of the course. But if you want to develop full application, yes, you have to get into the details about object-oriented concepts in Scala. But I will not be covering object-oriented programming in Scala as part of the course. The emphasis will be on Spark-based APIs in Scala and Python, but you will learn a little bit of Scala and Python as part of this course. I have already explained. The only scenario is because they are comfortable with Java, they chose to develop in Java. Okay. So I will take one more question before we wrap up for today. So one more thing is I am starting a big data engineer batch from September. So if any of your friends are interested, please let me know or please connect them to me. It will be 2-month course, and I will be clubbing the administration and the development in one course. And also I will be covering PIG also, which will not be covered as part of this course. It's a 2-month course. And the course fee will be around $350. I will be providing the lab from the developer perspective. I will be including capacity planning and all those things. For you guys, whoever is interested, I will take those topics after the course is completed. Those are not included in the course, but whoever is interested can be part of it, but it will be a little bit fast paced. Okay, but as part of the big data engineer course, I will be covering as part of the course itself, and I will not be emphasizing on HDFS and MapReduce up to the level I have emphasized as part of this course. We have spent a lot of time in those areas. As part of big data engineer course, I will not focus much on that. Instead, I will try to focus on breadth of the topics and lay a strong foundation for the big data engineer role. So if any of your friends are interested, please connect with me. And for MS students, the course will be free, but they might not be they need not join the regular classes. They can spend time on their own, and I will conduct hangouts on regular basis to clarify all their doubts. I will not be covering admin deeply in big data engineer course, but at a higher level, whatever is required for big data engineer, I will show that. I will provide those only those aspects. It will be only 6 hours part, but as part of the development effort, you will learn the architecture, and then once you understand the architecture, setting up the cluster will be relatively easy. Yes, Mohan, you can join. We can negotiate on the price. It will not be 350 for you, probably 100 or 150. We can decide on that, and you can join, but it will not be free completely. Okay. And a lot of stuff will be redundant. You don't need to spend or you don't need to join all the classes. I will share the plan with you guys. So whichever portion is relevant to you, you can join those portions only. Okay. Are you planning for DevOps engineer course? Yes, Pramod. Once this big data engineer course is properly structured on LMS platform, starting from November or December, I will work on a DevOps engineer course, and I will take batches also in DevOps engineer. But it will take long time. That is primarily targeting the MS students who will be passing out in 2017 and 18. Okay. Okay then. Thank you very much. We will catch up on day after tomorrow. Bye.